This tutorial will teach you how to graph a sine function. First, we need to get some information from the equation. To do that, you need to have your equation in a particular format. If it's not already cleaned up for you, you need to get the y alone on one side of the equal sign and the sine function on the other side. You want to make your equation look like the picture that you see in front of you. Y equals some value a times the sine of the quantity bx minus c plus d. Now it may be that you don't have a constant added at the end. There is no d, in which case the d would be a 0. If there's no number in front of the sine function, then your coefficient is a 1, just like you know from Algebra 1. Once you get your equation in the proper format, then you need to pick out your a, b, c, and d values. Every single time you graph a sine function, you list those 4 numbers. It's just like cooking. You get out all of your ingredients before you start to make sure that you have everything you need, they're ready and easy to grab when you need to use them. After you determine your a, b, and c, you need to find the same 4 things every time. The first is the amplitude. The amplitude is how tall your curve is going to be. So you measure the distance from the center line up to the top, and that's your amplitude. Because an amplitude is distance, it's the absolute value of your a number. It can't be negative. The next thing you need to figure out is the period. That's how long it takes before the curve repeats itself once and gets ready to do the same cycle over again. Your period is defined to be 2 pi divided by your b value. The next thing you need to find is the phase shift. The phase shift is defined to be c divided by b, and it's how far the entire curve is going to shift either to the left or to the right. If your phase shift is 0, it means you're starting from the origin. If your phase shift was, for instance, negative pi, that's where you would start your curve. The last thing you need to find is the vertical center. The vertical center is your d value. And the vertical center is the line, if you look at the graph, that would slice it right down the middle. Every time you do a sine graph, it's periodic. It's going to go from the center to the upper bound, back to the center, to the lower bound, back to the center, and then it's ready to repeat that same cycle all over again. Think of a bouncing ball. If you bounce a ball and it's starting from the floor and it bounces up and hits the upper boundary, it comes back down and hits the floor, that's your middle. It goes down into the basement, hits the lower boundary, and rebounds back up to the floor, and it's back to the middle again. And that's one complete cycle. So when you graph your curve, it's always going to look like this. We start at the middle, it bounces up to the upper bound, it comes back to that vertical center, it falls down to the lower bound, it comes back up to that vertical center, and it repeats that cycle over and over and over. The distance from that first middle to the third middle is one complete period. It's finished one complete curve, one upper mountain, if you will, one lower valley, if you will, and then it's going to just repeat that over and over again. Next example, your equation is y equals negative 3 times the sine of the quantity 2x plus pi plus 1. So when you compare it to the standard form, you can see that your a is negative 3 because that's the coefficient in front of sine. Your b is 2, that's the coefficient of x. Your c is negative pi because remember the standard equation has a minus there, so if there's a plus, you're thinking of it as minus negative pi. So your c is negative pi and your d is a positive 1. Make sure that you always list your a, b, c, and d values. The 4 things we need to calculate are the amplitude, the period, the phase shift, and the vertical center. The amplitude is the absolute value of a. Absolute value of negative 3 is positive 3. The period is 2 pi over b. 2 pi over 2 gives me pi. The phase shift is c over b negative pi over 2. And the vertical center is d equals 1. Now we need to scale the x-axis. So we're going to start at the phase shift at negative pi over 2. Normally we would start at 0, but the phase shift tells us we take the whole curve and shift it negative pi over 2 units to the left. Now we have to figure out how to put the numbers on the x-axis. So we're going to start at negative pi over 2 and we finish in pi. So if you add negative pi over 2 plus pi, which is our period, you're going to get pi over 2. That's where we're going to end on the right-hand side. If you go from negative pi over 2 at the beginning to pi over 2 at the end of one complete cycle, halfway in between that is 0. And then you need to take from negative pi over 2 to 0 and divide it in half to get negative pi over 4 to the left and positive pi over 4 to the right. And that's going to be your 4 points on your x-axis. And then the vertical center tells us we're shoving the whole curve up 1 unit. So instead of the x-axis being the vertical center, the 1 is the vertical center. So you go from 1 up to 3, which gives us 4 as our upper bound, and we go from 1 down to 3, which gives us negative 2 at the lower bound, and our curve is going to oscillate between those two values. Alright, so to repeat what we just said, now that we're looking at the axes themselves, we start at the phase shift, so not at 0 this time, but at negative pi over 2. On the right-hand side, we end at pi over 2, and we divide each of those segments in half. So we have negative pi over 4 to the left and positive pi over 4 to the right. Our vertical center this time is at 1, and from there we go up 3 and down 3. That's going to take us to 4 and negative 2, and our curve is going to oscillate between those two values. Then we put in the points, and remember, usually we go center up, center down. We are still going to start at our center, which is at negative pi over 2, but this time instead of going up, we're going down. Why? Because our a value is negative, not positive, and it says just reverse, do the opposite of what you'd normally do. So instead of going up, we're going to go down. So my first point again is at negative pi over 2. I go down 3 units to the negative 2. I come back up to the center at 1, and from that 1 I take the amplitude 3 and go from 1 up 3 to 4, my upper limit, back down to the center, and I've completed one period. And the last step is just to connect those dots with a smooth curve, and you've got your sine function. And now you're an expert on graphing sine functions.